mirror. You can be a hero. No matter what people say, you can change today. No matter what people do, they can do for you. Live a life, and you won't regret it when you die. Live a life, and you...
Hello, good afternoon, and greeting to my fellow luminarians. Thank you all for being here. So thanks for bearing with us through our schedule and delays. I think this is the third time this talk's been rescheduled for today. But I'm very happy to be here today with you all here in Bogota, talking about something near and dear to my heart, which is DevOps and how to do it in our modern cloud environments. So, production team, are we good to go? Should I just jump into it? Yeah, all right, slides. Oh man. So there's a whole bunch of stuff we're going to talk about. All right, what is the basis of DevOps? And that's empowering developers, taking code, getting it to prod as quickly as we can while keeping it safe. All right, now how do we do that? Well, we can build templates for our developers to use so that they can't accidentally do things that would hurt themselves. And then you put instrumentation, you put policies in place to detect if somebody does something they're not supposed to. So you can jump in and gently correct. If it turns into a pattern, you can take more aggressive results, but you don't have to go straight there, especially at the start. Now, what are some tools we use to do that? Well, we got continuous integration, continuous development. This is where I've been living at for the last 8 years in my career in Silicon Valley. Infrastructure as code, which has been really revolutionary in how we organize, build, and deploy cloud software. And the point being is making discrete units very repeatable so that when you deploy things, it's a comfortable situation. You do it a lot. If you do those things a lot, it's like exercise. You lift those weights. You get good at it. And each time, a little bit better than before. We serve as an advisor to the developments. All right, keeper of code. Talk about some role-based access controls, because you don't want people to do unsafe stuff inside your clouds. Some tips we can do to build security inside the software development lifecycle, especially things we can hook into our deployment pipelines so we get those security assurances automatically. And one of my more favorite parts is the really boring stuff about running infrastructure that really make a difference for security, and that's patching, key rotations, secrets rotations, tickets, and backups. And I'll get into details on all of that. All right? Some tips for those of us in the engineering set on how you can work with key stakeholders inside the organization to drive results, right? Technical problems are typically pretty easy. The issue is always boils down into meat space, we like to say, people to people. Right? And then new stuff, right? Running teams now that we live in a post-COVID world. Our industry is fundamentally different, and I don't see it ever reverting back to pre-COVID times. It's going to be remote first for the rest I can see. All right, slide. All right, so who am I? Why would you care? My name's Tyler, all right? I grew up on a horse farm in Arizona. I've been living in Silicon Valley 12 years now. Let's see. Got degrees, used to be in the Army, all right? When I went into industry, I started out in defense aerospace, launching satellites, and then made the jump into Silicon Valley startup scene 10 years ago. Worked all over in different types of roles, sales engineering, founding engineer, fintech, and all stages of company from seed through Series A up to and including IPO with Bill.com in 2019. I specialize in cloud, blockchain, crypto, fintech, and AI. All right. Currently, I'm an engineering manager at Support Logic. This is the slide deck that I'm using. We are a venture-backed AI customer sentiment analysis. We plug into CRM software, Salesforce, Zendesk. Used to provide hints on the health of accounts and how happy the customers are. So if you're having problem accounts, you can bring firepower to bear before it turns into an issue where you'd have trouble retaining that client in the future. And our customers include Salesforce, Palo Alto Network, Aruba, large enterprise technology companies that buy our stuff so they can get better insights into their customer interactions. I'm a board member on the Silicon Valley Information Security Systems Association. I advise, mentor, consult, and invest in early stage startups. And yeah, I focus in on security, compliance, infrastructure, and automation, and that'll be the basis for most of the things I talk about in my talk today. Slide, please. Thank you, sir. All right, so DevOps. What does DevOps do? Well, we keep the code. We deploy the code, run it, all right? Maintain compliance, make sure we do safe, make sure that we go to get our next compliance certification, we can get through that. And most importantly, we own the outcomes. The buck stops here. If there's anything going on in prod, it's me, all right? Now, while you can own the outcome, you're definitely not responsible for the whole process. And so things you'll do is serve as an advisor to the developers, to the management, right? Tear down silos. Oh, hey, I see you're building this as a Java web app, but maybe it'd make a little bit more sense if we use like a node container here and it's run a lot more lightweight, you know? Developer may not think about that because sometimes if you get really comfortable with your hammer, you want to use that hammer to solve every problem. And so you can come in and perhaps give them some better ideas. And as I mentioned, we own the infrastructure. All right, once that code gets into prod, now you've got sensitive customer data, and this is data that would have actual, real negative ramifications if it's to get dust. All right. All right, so using DevOps principles, we can abstract a lot of the implementation details that goes to running code in production away from the developers themselves. And what does that do? Well, developers can focus on writing functions. They can writing features and getting those to production much faster than they would be if they have to own the whole stack. Close the door. All right, slide. All right. So we break it down. We're tearing down barriers. In the old days, it used to be developers would write code and they'd throw it over the fence to operators. Operators pick the code up, deploy it, and run it. And never those paths would cross, right? The ops people are always complaining about developers writing terrible code, and the developers are always complaining about ops having crazy rules that aren't helping actually make better software. Because you have to understand the interests, the incentives for ops and developers are often not aligned in that particular arrangement. And so this is a product of shortening development cycles, increasing speed, so that we can get things out safer, all right? And Atlassian made this really cool figure 8. I don't know why people really like figure 8 pictures when it comes to DevOps stuff, but we'll start on this discovery part, right? Leads into planning, planning to build to test to deploy to operate, observe, and continuous feedback. And you'll notice this, we just keep going in this circle because this does not end. Slide. All right, so again, success in DevOps is empowering developers. Now, how do we do this? Well, we've got some tools we can use. Automation, right? Infrastructure as code, continuous integration, and continuous deployment, continuous development, and we'll give examples on all of that. But as I kind of hinted at earlier, most of the real problems boil down to the people space, right? We can build good tools, we can put them in place, but if there's not an understanding on who's responsible for what, you'll get gaps in accountability, and then that's where bad things can happen, outcome states. All right? So my job, right, connecting developers, owning the operations, and then more importantly, the other stakeholders, which is management, right? Making sure they're aware of the situations we face and solving problems, taking problems off of their plate. Slide. So, what is my goal in DevOps? We want to speed up release cycles and be able to reduce error rates and defects that would make their way into production before it can introduce risk into our application, risk into our operations, and risk it to our business itself. All right? End state would be enhanced customer satisfaction. If I lose my customers' data, they're going to be pissed off, all right? So first and foremost is keeping it safe, keeping it secure, keeping it private. We pay for that. We sign NDAs with our customers. Like the customer relationship databases that they share with us is very valuable data. And as such, we take measures to make sure we maintain the security of that. We talked about tearing down silos and ops engineerings. And the best way we can do this, right, to reduce this risk in getting code into prod is to do your bites in small steps, all right? Avoid big bang development cycles where, oh man, we're gonna build this whole thing. They call it the waterfall method. This is the first style of systems engineering that DoD was using in the 60s. Moved away from it because the problem with building software is you'll start with an idea of what it is you think you want, and it's not till you get some form of functionality in front of your users, whether that's internal users in your company or external customers that are actually paying the bills. They might change, they might decide they want something different. And if you have a long feedback time from when you can collect those requirements to when you can actually get some sort of semblance of a proof of concept in front of them, you end up building stuff they don't want. And that's a waste of money, that's a waste of time, and there are a few things in life I dislike more than having my time wasted. And so we can do some things to try and prevent that. And that's deploying often and testing always. All right, so how do we speed code to production safely? I touched on this in our intro. We use templates, all right? These templates will give standard methods to do what we might consider simple things. So you want to make a new UI, all right? Or you want to have a iframe that you'd insert inside your salesforce.com view. Or you'd want to deliver reports on a regular basis, right? Well, if you can give people a cookie cutter, that's what we're calling it inside my company. I've heard it called other stuff at other companies, but you give them a set of templates so that they're not starting from the ground up. They're not like, oh man, I want to deploy my software. Let's build a pipeline. Well, starting from zero and going to pipeline is very hard. If you can give someone a map on how to get there, you can do so much quicker. All right? Go ahead.
Are we allowed to ask questions?
Absolutely. I would love to keep this as interactive as possible. Yes, as you can see, while I have done quite a bit of public speaking, it still takes a little bit for me to break out of my shell. So please, bring it out.
So we can ask.
Yes, we'll have questions at the very end, but by no means feel shy about raising your hands. Yes, please.
My question is for continuous deployment and for sharing templates with engineers. For continuous deployment and sharing templates with engineering, what role in your existing or previous organizations does QA play in the development and maintenance of those templates? Or more broadly, how do you see QA, like what is the role of QA in this style of development?
They're complementary to each other, right? In my companies today and at previous ones, QA had influence and like opinions they would share on how these templates are constructed. But it's operations, cloud infrastructure, who own the platform engineering portion of building these templates that we provide to the developers. QA, at a most basic level, is proving that the software that is being delivered in this build conforms to its requirements, does what it says it's going to do, right? Doesn't have secondary behavior that may introduce unexpected features, right? Which unexpected behavior in enterprise applications typically are bad. This is where your security vulnerabilities come in. But we use QA as the gatekeepers on that quality specific to functionality, right? We have these many tickets assigned to this build, right? We're going to make sure we can meet all these tickets. This ticket we didn't meet, okay, this one feature is going to move into a next build. And at my company, they actually are, like DevOps, we built the tooling they use to do the deployments. We built the deployment pipelines, but it's QA who's actually pulling the trigger and rolling that software out to customer environments. It's an engineering It's an engineering question, right? And here's a cheat code on answering engineering questions. The answer is always, it depends. You can slice that cake different ways. It's just important that you have it documented and that those responsibilities, who owns them? They know they own them. Yep. Fantastic question. Thank you so much. All right. And policy guardrails and security controls. So while we've built templates, we give them to our developers. We've got some security tooling that we'll run in our cloud to make sure people aren't doing stuff they're not supposed to. Lacework's the vendor I'm using right now. When they'll do some AI stuff based on agents that run on our Linux systems. And if stuff is happening in the cloud that doesn't happen before, it generates an alarm, which goes to my NOC, SOC. Oh yeah, we'll get there. You got a question?
How do you manage the security controls over agents when you are working on artificial intelligence? Oh.
Go ahead.
How do you manage the guardrails and security control when you are working with agents or LLMs, big LLMs?
Oh, that's a very good question. Right?
Thank you.
So this is actually a question that comes up to our end customers a lot because we provide large language models to feature functionality to our end customers. One of the things they'll do is called a case summary, right? Where you'll plug your Salesforce or your Zendesk ticket in here. We do run an LLM on it and then construct it down into like a 3-sentence paragraph. Well, if you're paying for OpenAI, right? You're on their corporate model. You own the abstract models that you use to feed it. This doesn't apply to the free options, right? And that's what will push you to do it. Now, some of our customers, they don't like OpenAI. It's scary. Oh my God, that guy seems freaky when I see him talk on stage, right? So we swap out other ones. We'll have Anthropic, who just got, I think purchased by Amazon for a few billion. And then we are in the process of building our own custom LLMs so that we can swap them out. If it turns into an issue where the customer has concern, we'll give them one that they are a little bit more comfy with, right? And if it's roll our own LLMs, it lives 100% inside my infrastructure, so I don't have to worry about that data leaking out, right? But it's a very good question. It's something you want to consider, and it's why if you have data privacy concerns, you pay for the enterprise tooling so that you can maintain stewardship of that data. Does that answer your question? You're welcome, man. And thank you for your question. Please keep them coming. All right? But the security controls that I have in place are mandated by the compliance needs that my company has, which is SOC 2 and ISO 27001. And so the ISO standard has a set of security requirements. We break those requirements into features that I apply inside my infrastructure and then map those to controls. And then that's what we prove to the auditor. Oh yes, hey, we aren't making changes in prod unless we have a ticket, right? And then those changes are, while they'll be proposed from a developer, it's actually a deciding authority and an engineering manager who would have the ability to bless it. And then at that point, go nuts. All right? And so these kind of templates are platform engineering, right? We want to create reusable self-service platforms developers to leverage, because if I am blocking developers from getting their work done, that's not going to be career enhancing to me, right? I want to create a good, pleasant experience for the developers that I support, because that's what builds, good teamwork, right? And successful outcomes over the long term. So one of the neat things you can do about this too, and this is why developers love it, right? You give them the power to own the outcome all the way to production, all right? Netflix calls this full cycle development, where it's not just, okay, you're going to build this feature, right? But now you're going to own it, test it, deploy it, and monitor it in production. And one of the nice side effects from a people management perspective on this is that because you're owning the outcome, it's not like you're just pushing code into a hole and then you have no idea. You get to see that customer joy, right? You get to see people that like what you're building. And that gets your developer fired up, keeps you interested in the problem, and keeps you building. Slide. So, this was just a really fun slide I found on the internet that I figured slay because it's here. Whenever you build a company, right, you're not going to be coming out of the box with a platform engineering developer portal, push button, get my Git repository, and then the pipeline to deploy it, all the security tooling, right? But our jobs as owners, right, is to identify where you're at in this journey, right, and build a plan to get you pushed up that level. And so, step one, you've got your single developer who's just been building it himself. I don't need automation. I can just push that to GitHub pages. And look, it's self-hosted. No problem, right? Then you go, all right, well, maybe we need to get some features done, and we don't have enough people or this guy doesn't have enough hours in the day to deliver these features for our customers to grow the company. This is where you need to start adding these automations in, these tooling, because ultimately you're coordinating work between different people, and you want to get them to be able to do that safely without stepping on each other's feet. So, from lack of capability to custom solutions, to reusable and centralized artifacts, all right, to automated bootstrapping, and this is where I'd say my company's at right now, okay? Where we've just moved out of the reusable and centralized artifacts to now I'm starting to give those tools to our end developers so that we can get them to their code to prod. Slide. Cool. All right, so how do we do this? Well, it's not an easy problem because there's a lot of different things to consider, all right? What do you need to do when you modify your configuration of your application, right? How about when you need to specify environment variables? How do you update those? How do you track what they are over time? How do you manage that at scale across, let's say, hypothetically 130 customer VPCs, which are all operate on their own island and their own network? How do you build in new services and dependencies as you scale? Because if you consider that single VPC model I did, it's going to scale end-to-end geometrically, right? Each additional feature is now being applied to 130 environments. Never mind closing more customers. So now as you continue to scale the business, while you're adding all these additional features, it starts to get real big, and that's why we got to use tools. Rollback, right? Oh man, we did a build, but there's a problem. We need to get that back out. Well, how can you do that quickly? I sure hope it's a pipeline, because if it's a guy slinging bash commands, it's way too easy to shoot yourself in the foot. Creating new environments, adding resources, and then enforcing role-based access controls, which we will talk about very soon. All right. So, sir, Patrick.
Okay. Obviously, there's a lot of steps and everything when it comes to getting things onto prod or just getting prod out in general. Let's say you had 2 days for a hackathon to put together a project on something that is very new to you. What is your wireframe to get something out in 48 hours?
Hack. Caffeine, bro. Yeah. So it's interesting you mentioned that, because that's really the distinction between hackathons and then moving to an enterprise application, right? Mm-hmm. You don't have those security concerns. You don't need to be worried about your SOC 2 compliance. Yeah. And what's the actual risk of that compromise in that data? There is no risk, so you don't need to be really safe and be careful, because excuse my French, F it up, man. Yeah. Lean into it hard. If you fall on your face, maybe you won't win this hackathon. But
break prod a lot.
Yeah, break it. Yeah. Go for it, dude. Hack the planet. Okay, perfect. But if I was hinting you guys, I sure like pipelines, and GitHub Actions is pretty cheap.
So I guess in essence, even if it's broken, push to prod.
Yes. Well, yeah. No. If it's broken, what's the risk? Exactly. You can't make it more broke. So all you can do is get better from there. Yeah. So, yeah, the hardest problem is 0 to 1, and there are gotchas. There are some things I'm abstracting away from those details. Like wise systems engineers would tell you, be careful with what you get to prod, because once it gets there, it's never getting out. And that hacky, terrible PHP, garbage code. You'll have somebody cleaning it up for as long as the company is in existence. So be careful.
So I guess the only caveat that I'll add is don't push your keys.
Yeah. That goes without saying. Secrets management's no joke, and
okay, sweet.
I hope you don't have to learn that one the hard way.
Yeah, don't do that.
I've seen it, man.
And commit history lives forever.
Anybody aware of the LastPass hack that took place a year ago? Well, unfortunately, everyone who'd put their Bitcoin seed phrases in as secure notes, it was actually weirdly stored as plain text on their servers. So, oh yeah. So some metadata was encrypted, some core components weren't, but if you didn't have a really strong master password, the problem is with these cloud resources, I can hire out Amazon GPUs for $20K a day. If I'm cracking 4 wallets that are holding 3 million, it's a good return on investment. And so, yeah, use long passwords, use password managers, be careful where you put your data.
Try not to use get ignore if you don't have to, but just keep your keys out of the environment entirely unless you're staying local.
Yeah.
Cool. Thank you.
Yeah, no, I appreciate it. So why is integration hard on this, right? And I kind of touched on that. So hackathon, right? 2 to 3, you can do the big bang. Screw it, let's launch it, all right? But now you've got your requirements continue to scale. You have to maintain the security of your customers' data, and now you need to start having people specialize into roles so that you can continue to deliver features. System complexity scales exponentially, right? It's end-to-end. I was trying to hint at that with the geometric scale I touched on. But point-to-point interaction starts getting very hard to keep your arms around, and so you have to use technology to manage that. All right. And so this is one of the best tools that we have at our disposal, which is continuous integration, continuous delivery, and continuous deployment. All right? So the big bang, the problem with that is it leads to what we like to call affectionately integration hell, right? We've delivered, and now system no worky, and now you need to figure out where things are breaking. And depending how many subsystems, what those interfaces look like, and the complexity of the requirements you're trying to meet, this can get very obtuse very quickly. This is the classic problem that hurts DoD system development, right? Build really complex requirements. Everybody's building their own subsystems together. You push them together, you bring those subsystems together, turn it on, and nobody wants to play nice to each other. No data flow through, and yeah. So what do we do to fix that? Deploy all the time. Go ahead, Ming.
My question is, when you use the term integrate here, are you strictly referring to internal integrations, or what role do third-party integrations play in continuous deployment with this design?
I mean, once again, it depends. But so what I'm referring to here is within my system so this is mostly internal.
Okay.
Now we may pull in external tools, like we use something called Launch Darkly if we want to allow certain features to some customers but not others. And another one would be like Pendo, right? For what does our customer interaction look like into our application? But honestly, for me as the DevOps manager for my company, those integrations are afterthoughts, right? Those show up in the end state in the UI, right? And it's not like the load that it's placed is not on my servers. That load is on the client's computer and then the cloud servers that Pendo and Launch Darkly host. So my focus on this talk is primarily internal, all right? But you might have critical dependencies on external providers.
That's right.
Say Splunk, if you need to run a SOC, right? You need to push your data to Splunk so that you can do data analysis on it. Or what would be another one? We have a provider called Fivetran, and that's the one that we use to do the ETLs from CRM software into our database. Once it gets into Postgres on our side, then we do the transformations and run ML models against it to deliver the sentiments.
I think on some level it would be a case-by-case basis because third parties vary in the level of dependency an organization has on their footprint.
Absolutely, because it all boils down, what are the requirements you're trying to meet? And if those requirements depend on those third parties, then hell yeah, they got to be in this loop. But if not, well, then we could just abstract it away. All right, so how do we do this? We push code to a shared repository. I use Git. You should use Git too. I am a GitOps evangelist, I guess you would say. Where does truth live? Truth lives in Git. If it's not in Git, How do I know you didn't just make it up? You going into my servers and editing the config files manually? Oh man, you do another deployment, that's gone. Or maybe your VM falls over and you get a new one spun up. Or you autoscale. And those configs, if they're not persisted from there and being deployed as part of this, well, you just lost that configuration. Now you're introducing unknown states into your application, and this makes for very uncomfortable situations if you are having errant behaviors. All right? So automation will take that code, deploy it to a test environment, and now the developer will validate that the code that they thought they had built on their system is now working in that test environment as expected. And why do we do this? If you ever want to piss me off at work, you say, oh, it works on my machine. Oh man, that's not an answer. Like, no, I don't pay you to make code work inside your sandbox. I pay you to make code that works inside our system of systems, okay? So, how do you fight that? You make them play in the sandbox. And we do that by, instead of not letting the developers push the code out, they write their code, and then you deploy it there as it needs to. One thing I'd want to mention here, all right? This one is contentious. Those people have strong opinions on code automatically getting to production. And I actually am in the favor of not doing that. I still want a human in the loop. I don't want code getting pushed to prod until I go in and push that button, right? Because it's just too easy for weird things to happen. Okay, slide. All right. Oh, go ahead. No, it's conversation.
Continuous deployment doesn't only refer to manual versus automatic push to prod, does it? Because
they're drawing the line between continuous delivery, which is deploying it to those test environments, to continuous deployment, where they're pushing it to prod, just in the way that they just did that discrete step between.
Yeah, I see what you're saying. So continuous delivery is we're pushing every 2 weeks,
it's one of those
but it's
nomenclature
manual.
things, and I've seen it used in both ways.
Okay.
It really depends on how you slice that pie.
Okay, thanks.
Yeah, for sure. All right. So how do we do CI/CD? Well, like everything, we put it into code. All right. And there's many tools you can use to build your CI/CD pipelines. Jenkins was the first one I used at. GitHub, which is nice because GitHub's free. They get some GitHub's actions. Check it out. All right. The only thing I don't like about that is you don't get a lot of firm control over VMs, and it's hard to instrument that. GitLab, which is what we used at Bill.com, pretty nifty. And then Circle CI, because that's what I'm using today at Support Project. But what I've got here is just a snapshot of what a pipeline definition in Circle CI would look like. Gets checked in as a .circleci file into the repo. We've got an integration with GitHub. So if it sees that Circle CI file show up, you get a pipeline based on how this definition is built. All right. Branching. So now you've got different developers working on different features, right? And probably several test environments. How do you keep from stepping on each other? Well, you have certain code that deploys from some branches and other code that deploys from others. Okay? And you can pick where it goes. So this is actually engineering products from my company, right? This is how we do our QA. If we branch off into project, features, libraries, trunk, and develop, you work on your development branch, and then you do a PR to bring a merge request to bring those changes back and develop. And then that becomes like the core of the code that you maintain rolling forward. And then if you're going to cut a branch for release, right? Bam, you cut it to release. QA jumps in at that point. They test it fully, and then that release tag is what actually, or that tag to that specific release is what actually gets pushed out for that particular deployment. Slide. So we talked about CI/CD. Now, this is where it starts to get really neat. Infrastructure is code, all right? The big thing for me as systems engineer is repeatability, all right? And one of the things that really got me when I was first learning this cloud stuff is Amazon builds this really pretty UI. You log in, and you're like, oh, I want a VM, let's go click it. We give me a VM, and you start pushing buttons, you get the parameters, all right? Now, how are you going to redeploy that VM? Do you write a set of steps, and then you just go through and code monkey your way to click through this? No. We write these definitions down in code, in text, right? And we build pipelines so that when we update our definitions, it updates the infrastructure. And what this does, it lets you spin up new infrastructure very quickly, revert changes to your infrastructure very quickly if you break something. And this is the way to do it, right? I started out with cloud formation templates in AWS, and the whole industry is pretty much migrated over to Terraform. So, you guys want to make yourself valuable? Learn Terraform. There is a lot of demand for it in the market right now. And if you learn Terraform, send me a message. I'll hire you. All right? So, Zen and the art of infrastructure and code. Putting all these pieces together so we can get there. And it's starting from Git, moving to Terraform. You take your Terraform, put it into Git. That drives a pipeline. And that pipeline builds your cloud infrastructure. So Git's source control, all right? You can have developers work on the same code base, make changes, not step on each other, and then keep that history. Who changed what, when, and why? Because that's really important for compliance needs. And then also when things break, you can do Git history and see, you have that line up with your pipeline output, and you say, oh man, John, what did you do? You're breaking my code. Stop it. You revert, try again. So Terraform, we talked about that. It's a declarative language. You say, hey, I want this end state. You say Terraform plan. It builds you a plan to take what you have in your current infrastructure and then modify it to get to the new state. And maybe you're doing something like just updating a single parameter on your VM. It'll be a pretty quick change. Or say you're going to build an entire, rebuild your infrastructure in a new region. Well, that's probably load balancers. You've got your cloud buckets, your SQL servers, and a lot more things would change as a result of that. Pipeline, CI/CD. All right, pipeline is an instance. Hello. Okay. So, I don't know. Excuse me. Sure. Check. All right. And then cloud infra. That's what you're actually building up in the cloud. That hosts your code, responds to requests, and provides those services to your end customer. So, what do we get? It's cool. It's a lot of work, but when you go through the work, you get this value. Platforms become composable, disaggregated, right? The result, your platform is elastic and open. The value, disconnects software from the hardware. And that's a really cool one for me as a systems engineer. I like abstraction because that allows you to test, build, as it says, speed, efficiency, and agility. Get that code to prod faster, safely. Automation, all right? Not just configuration and provisioning, but now I want to deliver IT capability, whether that's, what would be a good example? Like OAuth 2 authentication services, right? We could deploy that just as a single unit. And you don't have to worry about potential side effects, especially if you want to build like a full copy of it for a development environment, a staging environment, and then production environment. So you can run this, you can be certain you're running the same copy of your code at this different level, the same copy of the infrastructure at different levels. And then, because I will tell you, that's one of the harder things to diagnose in real life, is when things start working differently in prod from how they did in staging. And now you have to put on your detective hat and step into the crime scene. All right, why? And it depends. And then policies are driven, right? Go ahead.
What do you measure the speed, efficiency, agility that you, how do you measure the improving the speed?
So that's a very, yeah.
The code into infrastructure.
So it's how you measure developer efficiency and effectiveness is a very contentious question, but I will give you my best opportunity at distilling that into a small answer. In my mind, it's how quickly you can take a concept, all right, get it built, get it tested, and get it pushed out to prod with a minimum amount of people involved in that process. So I like to think of it as time from inception to release is how you would measure that. And so as you add additional automations and provide additional tooling to the developers, you can make that go much, much faster. And so that's what I look for, right? One is developer happiness. How happy are my developers with the things that I'm providing to them? Are they having specific pain points that I can take that away? And the other one is how quickly they can take ideas and get them into production without me having to babysit and marshal that process. Because how do you measure it? Jira. Jira, code commits, right? You write a feature in Jira, all right? You commit your code, you link your code updates to that Jira ticket. This is how I do it in industry, right? And then those tickets become linked to a specific release in our deployment process. And so from when the product manager is like, oh man, we got to have this feature so we can close this business. Like we need to get this new customer. All right? If that's an 8-month process, maybe it's a really complex feature and it's going to take time to integrate. You know, it does. But let's say they want to change the color of a button on the UI. That should not need 5 people involved. And so that's what I look for. How quickly from Jira to code to test to prod. And then once you're tracking that, then you just, the objective becomes to shorten that. You're very welcome, and thank you. More questions, very welcomed. Slide, please. All right, so how do we do this safely? All right, I've talked about our development environments. Yes, you don't go straight to prod. You got to run it in your development. Got to run it in testing. All right. And what do? I define the burden of proof. I define the requirements that you need to do in order to move from one level to the next. Now, part of this is putting the burden of proof on the developer. All right? Prove to me your code is safe. All right? But I'll give you some tools to help prove that. So there's things that we check. Functionality, right? That's the first one. That's the like, oh, it works on my machine. Okay, cool. All right? Now it works in my development environment. Great. Code sanitary checks, right? Are you doing things in just we'll run code scanning tools and see if you're doing things that we know are probably unsafe already. Maybe I'll use C examples because they're so meaty, right? You're initializing a variable without actually setting it, right? So you've allocated this memory space, but you don't know what lives in that memory. Then you start writing a buffer, but you're not actually checking the size of your buffer. Oh man, you overflow your buffer. Usually going to have a bad time, especially if you're running that code in kernel space. Now you've just rootkitted yourself, all right? So code sanitary checks, security testing, and I'll talk a little bit more about this in a bit. All right, so we want to build confidence in our code, make sure it's relatively free of defects. Stuff will always creep in, but the idea is to limit the impact of those vulnerabilities through additional controls we place around it as we go from one level to the next. And find those defects before they get to a point where they can cause damage to our company, cause damage to the confidence in our application from our customers, keep the business safe. Slide. So, one of the things we can do is called role-based access controls, all right? Mapping permissions to users is scary and dangerous, and as your company grows, it becomes an unmanageable problem, all right? The danger here is you'll get more permissions than you need to actually get your job done. And then once you have these permissions assigned, it's very rare that they'll come back and get kicked off. All right. So what we do is we divide roles and responsibilities into discrete groups, and we assign permissions. And this is in the context of maybe GitHub and also cloud permissions themselves. And here's an example I'll give you. This is hypothetical. We've got a machine learning engineer in my company. Probably doesn't need to be updating my cloud audit logging. And moreover, if I see an ML engineer messing around with my cloud audit logging, I'll say, hey buddy, what are you doing? Because like, I'm gonna assume it's, has wholesome intentions, but we always have to maintain, as a security practitioner, which I do self-identify as, we have to maintain suspicion. So here's an example, and this was one I made up pretty quick. Developer, you're going to commit code to repo, you're going to do a code review, you're going to do an MR approval, all right? But as a developer, I'm not going to give you rights to promote your code from development to testing. That we would leave at QA, where they decide they want to then bring that up to the test environment and bring that out. Go ahead, Meg.
What happens if you don't have a QA team?
Your developers are doing QA. Yeah, you do have a QA. It just means that responsibility, instead of it being owned by a separate team, now is owned by the developers. But if you think about what quality assurance means, right? A lot of the things I'm building into this process is to make sure that we're delivering quality, right? And so you can own it, but it's a very deep question, right? Because, and it gets into, especially when you start talking about coding practices, becomes a religious discussion for some. And it's become hip to break down QA teams in the Valley in the last 5 years. Like they're going away because now they just want the developers to be able to own that quality assurance. However, other organizations, banks, right, they want to have that separation of responsibilities so that people who write the code aren't also being the ones proving that it's executing correctly. So, not to be that guy, it depends. All right.
Because it works on my machine.
Yeah. Yes, exactly.
Because it works on my machine.
Yeah. So you can use CI/CD tooling to eliminate QA if you need to, but like in practice, at least at my company today, I offload a lot of work onto QA as far as making sure we meet those requirements in the tickets themselves, and then also having them manage the deployment. Like I'll build the tools, right? You use my tools, but I'll let, I don't want to insert myself into the process unless it absolutely need to be there. And yeah, oh look, here's a cool picture about what role-based access control is I found on the internet. Sweet, permissions are authorized for specific roles. Role-based access control is big in databases, big in cloud. We're not the first people to use it, but the extra step here is taking your users and then mapping those cloud permissions into those roles themselves. And this is stuff I get asked about from my auditors when I go through my compliance recertifications. So. All right, so what are some things we can do to build security into your software development lifecycle? All right, well, the biggest is code reviews, right? Humans in the loop, all right? Having one person writing code, committing it themselves. Fact of the matter is, you don't know what you don't know, right? I know a lot of things, but there's a whole bunch more stuff that I don't know. And what the scary part about that is I can't even get my arms around what that I don't know. So one of the ways we can fight this in practice and industry, use more eyeballs, more perspectives. I mean, this is the major argument for having diverse development teams, right? As opposed to the monoculture of Silicon Valley that's been so, you know, so funny for the last bit. Because different upbringings, different perspectives, different experiences lead to different things that you might be concerned about. And so the goal here is to, again, deliver safe software. And by getting more perspectives, probably going to get safer software as a result of that. And then me, right, as a tool builder, platform provider, I can take my CI/CD pipelines and start building security testing into them, all right? Whether that's functional tests, whether you're driving like a Selenium to actually jump in, click the UI, and then exercise whatever it is you're trying to build. Static analysis security testing, where we'll take the code, look at it, run it through a rules engine, and see if you're doing stuff that might be dangerous. Dynamic analysis security testing, and I got a slide for this, so we'll go to those, yeah. Here we go. So we'll take your app, we'll rip it apart in a non-running state. All right, the one we used at Build.com was Veracode. At my job today, I'm using Shift Left. They've just rebranded to Quiet AI. But at a certain point, your customers will demand that you have this in your development process. And the earlier you get it in there, the less pain it will be for when you need to incorporate those. All right, cool things about SaaS, no more manual checks. It's in the pipeline, it just happens automatically, right? And because we're doing these checks before it's even been deployed to that development environment, the thing to remember is the earlier we detect these code quality issues, the cheaper they are to fix. Problems that get to prod can get very expensive to unwind, especially if you start corrupting your data, and then you have to unwind that corruption. So be careful. There are disadvantages, right? You need your source code. Not a problem for me because I own it in there, but if you're buying COTS, they're probably not going to give you the source code. So you have to either ask that they did it or just believe that they did. And the other thing is, like, typically SaaS just produces a shit ton of findings. And, you know, maybe in practice 10 to 15% of them will be actual real vulnerabilities. So you'll get a lot of extra work of having to go through and validate finding. Is this a real finding? No, it's actually not a finding. And then, got to do your homework, got to do your accounting. Okay, that's about enough on that one. We'll go to the next. Dynamic, all right? So this is more what you'd see with like the OWASP top 10 tooling, right? We want to put your code in a running state and then beat up on it to try and get it to do weird things. Fuzzing, if anybody's familiar with that, is a form of dynamic application security testing. I'm a fan of fuzzing. I wrote my master's thesis on it. All right. But for me as an operator of infrastructure, what does this mean in practice? It means I buy tooling and I build it into our system. And then that tooling gives me an extra measure of warm, fuzzy feelings that I'm doing stuff safely. All right. Set SCA, ignore this picture. Like I couldn't find it at disadvantage of SCA because there really is none, right? SCA is taking at the list, the libraries you're putting into your program, whether that's NPM packages or Python libraries or C import statements, all right? Because you're not going to write printf. I don't want to write a bubble sort. Somebody's done that a bunch. So I'll just pull this one off the library, NPM import, bubble sort. Oh, shucks, man. Little did you realize that that's got a, CVS level 10. Like they just pwned your website and you have no idea because you just use this public library. So what do people do? They'll have known lists of vulnerabilities for public libraries, and then they'll just do a simple check. Hey, you're using these libraries. Do any of them have any known findings? And if so, maybe use a different one, or use a later version, or find a different way to solve that problem. Slide. So other things we do in the software development lifecycle. So now we're getting into the more expensive stuff, all right? You hire external pen testers. You hire expert hackers to come and beat up on your stuff. Again, I can't see what I can't see, and all of these bad guys typically have different ways they like to solve these problems. And moreover, I have to do this for my SOC 2 compliance. So when I get back from Columbia, I'm going to go find myself a red team. Most important thing on this slide, though, right? All of this is going to give you some measure of signal on the quality of your code, potential vulnerabilities. You have to have a process defined in order to receive these vulnerabilities and respond to them, actually address them. So it's really cool. You can hire the best pen testers on earth, spend $100,000, right? They brute force your system for a month straight. And they give you a book of findings, right? Now, if that book just goes onto the shelf and sits there collecting dust, you just wasted that money, all right? So have a plan before you hire people to bring you all these findings on what you're going to do once you have those findings in hand, all right? And then pro tip that I will just tell about everyone if you're running software, have a responsible disclosure program. Have a way for people to give you vulnerabilities. Hey, on your website, if you have a finding, please contact security@supportlogic.io. My SOC team is watching that 24/7. If it's a real finding, I might even give you money. But if there's no way for people to bring you those vulnerabilities, you're losing all of that free. It's free. It's free. People want to help, right? So there's no disadvantage. But definitely, it's supposed to say investigate, pardon me, and fix the things they report if they're valid. It's like, cool. And now how do we put it all together? Look at this really pretty slide, all right? Start from the plan. Security training for developers. Make sure they know not to do dangerous stuff while they're building it. Code, all right? We're doing our SAT, our source composition analysis, our static code analysis, right as we check this code in, because it's built into our pipelines. Build, all right? This is where you get into the more dynamic testing. Use those externally hosted tools to try and break in, see if they can find cross-site scripting being a big one they find with these tools, right? And vulnerability assessment. Deploy, and then operate. That's where you get into your pen testing. But shift left being the very cool, hip thing you'll hear in security space, at least in the last 5 years. The earlier you can get the security testing into your system, the cheaper it will be to fix the vulnerabilities that may exist. There are no magic bullets here, all right? Security assurance comes from a layered approach. And the security is cheaper the earlier you get it into the process.
Man in the mirror, you can be a hero.